More than one answer. So an equation can have more than one solution. If applying the power rule results in a quadratic equation, always check both solutions. Maybe they both work, maybe one works, maybe none works. Here's our first one. All right, so we have the square root of 9x plus 7 equals x plus 3. So we're going to square both sides first. We've already got it isolated. We've got our radical isolated. Remember to FOIL to multiply a binomial by itself. Then factor and set each factor equal to 0 to solve. Right? So let's square both sides. We have the square root of 9x plus 7 squared equals x plus 3 squared. Square and square root cancel on this side. We have 9x plus 7. On the other side, we have x plus 3 times x plus 3. Do not distribute a square. It is wrong. Right? You will see when we multiply, so square means multiply by itself. You will see when we multiply it by itself, we do not end up with x squared plus 9. All right, so we have 9x plus 7 equals. All right, so now a FOIL. So first, x times x is going to give us x squared. The outer terms, x times 3, it's going to be 3x. The inner terms, 3 times x, it's going to be 3x. And then the last terms, plus 9. So notice we have 4 terms, 2 of which we can combine. So we have 9x plus 7 equals x squared plus 6x plus 9. Now we need to get everything over to one side. It makes sense to move it to the right. So we're going to subtract 9x and subtract 7. Subtract 9x and subtract 7. So that gives us 0 equals, got to be equal to 0 to solve a quadratic, equals x squared minus 3x plus 2. Right? 6 minus 9 is negative 3. 9 minus 7 is 2. All right, so now we'll factor. 1 times 2, a times c, right? 1 times 2 is 2. We need two numbers that multiply to give us 2, add to give us our b term of negative 3. Okay? Well, 2 only has two factors, 2 and 1. If they're going to add to negative 3, they have to both be negative. Right? So we have 0 equals x squared minus 2x plus negative x plus 2. And the first two are a group and the second two are a group, plus your greatest common factor. Right, so for x squared and negative 2x, that's going to be an x. And if we divide x squared minus 2x by x, we'd have x minus 2. And then negative x plus 2, we're going to factor out a negative 1. And if we divide those both by negative 1, we have x minus 2. Right, so the repeating x minus 2 is one solution. What we factored out, oops, we lost the 1 there. What we factored out, x minus 1, is the other one. So that means we have two solutions. Let's see if I can move everything up a little bit. Oops, well, I lost that side. That's right. There, that gives us a little bit more space. Let's just move. Oh, this might be locked in there. It's locked in there. It's okay. All right, so if we set each of our factors equal to 0, x minus 2 equals 0, so x is 2. X minus 7 equals 0, x is 7. So on these ones, you're going to have a quadratic you can factor. And I do mean factor. Don't use completing the square. Don't use quadratic formula. Factor, all right? These are going to be rational solutions, or they're not going to work at all anyway. So all you're going to get are rational solutions here. So factor. All right, so now let's check our solutions. All right, so it was 2 and 7, right? 2 and 7. And by the way, factor means factor completely. All right, I didn't stop halfway, all right, anywhere. All right, so my third to last step has my two factors multiplied one another. That's what it means to factor. The second to last step, I set them equal to 0, and then finally I have my solutions. So 2 and 7. All right, so let's check 2 and 7. I gave us a second page to do all our checks on. All right, so we have the square root of 9 times 2 plus 7 equals 2 plus 3. Square root of 9 times 2 is 18, plus 7 equals 2 plus 3. That would be the square root of 25, which is 5, which equals 2 plus 3. That one checks out. That one is a solution. Give it a happy face. Let's check the other solution, which is 7. So we have the square root of 9 times 7 plus 7 equals 7 plus 3. 9 times 7 is 63 plus 7 equals 7 plus 3 is, did I put the right numbers in there? All right, stop for a second. Somehow my -1 morphed into a 7. I'm solving it out and I'm going, this doesn't make any sense at all. I have no idea. Probably I just wrote it sloppy because I'm kind of like leaning over. And so x minus 1 equals 7. X minus 1 equals 0. I don't know what it is about 7 today. X equals 1. All right, now let's check the correct solutions in there. No explanation for the 7. Doesn't make any sense at all. Make sure you don't copy the 7. All right. 1. All right. I guess the number got messier and messier as I went along, and somehow it became a 7. All right, so we have 9 times, let's just erase everything. Just erase everything. All right. Continue checking. 9 times 1 plus 7 equals 1 plus 3. So that's going to be 9 plus 7, which is 16. And the square root of 16 is 4. So that one checks out as well. Oops, excuse me. Decided to write a radical with it. Must be getting tired. And when you take the square root, there's no more radical left. Well, these little things give me a chance to remind you of some key things. And give it a smiley face because they're both solutions. So x equals 2 and x equals 1 both worked in this case. All right, so let's try another one. All right, so here we have x minus 4 equals the square root of x plus 2. Remember to square both sides. We have x minus 4 squared equals the square root of x plus 2 squared. Don't forget to expand to square your binomial. So this is going to be x minus 4 times x minus 4 equals, all right, and square root cancel, so this would be x plus 2. Now we'll square, right? So the first time, and we'll multiply the first terms. X times x is x squared. The outer terms, -4 times x is -4x. The inner terms, -4 times x is -4x. And the last terms, -4 times -4 is a positive 16. Let's combine our like terms. So we have x squared minus 8x plus 16 equals x plus 2. Maybe I should do a few of these with distribution, right? Just to remind you of what distribution looks like, which is the reverse factoring. Let's get everything over to one side. So we'll subtract x and subtract 2. So we have x squared minus 9x plus 14 equals 0. All right, so 1 times 14 is 14, multiplies to give us 14, but adds to give us our b term of 9. Of course, that's 2 and 7. Maybe I was thinking of the next answer on the last problem. 7 is coming up. So we have x squared minus 2x, excuse me, plus 2, yes, minus. It's minus 9, minus 9. They're all negatives, negative, 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 negative. Right, so they multiply to give you 14, add to give you -9. 7 and 2 are going to be negative. So x squared minus 2x plus -7x plus 14. And the first two are our group. The second two are our group. We'll factor out a greatest common factor, which would be an x from the first terms. If we divide both of those by x, we have x minus 2. Greatest common factor are -7. Divide both of those by -7, and we get x minus 2. Right, so the repeating x minus 2 is one factor. What we factored out, the x minus 7 is the other. And somehow we lost our 0, probably because there's no space. All right, and so now Let's solve for x. So we have x minus 2 equals 0, x equals 2, x minus 7 equals 0, x is 7. So let's check 2 and 7 on the next page. 2 and 7, 2 and 7. All right, so we have, this is x equals 2. We have 2 minus 4 equals the square root of 2 plus 2. 2 minus 4 is negative 2. That would be the square root of 4, which is 2. And negative 2 does not equal 2. So this is an extraneous solution. All right, let's check out our other solution, which is the 7. All right, so this is x equals 7. So we have 7 minus 4 equals the square root of 7 plus 2. 7 minus 4 is 3. So 3 equals the square root of 9 is a true statement. All right, and so this one here is a solution. The other one was an extraneous solution. And we'll give it a happy face. That's a weird happy face. There we go. And of course this one would get a sad face. All right, let's continue on. If any term is on the same side as the radical expression, isolate the radical expression first, then raise to the power. So here we don't want to leave that 6 with the radical. We want to move the 6 to the other side. Right? So we'll subtract 6 from both sides. That gives us the square root of x minus 4 equals x minus 6. Now we'll square to get rid of the radical. And then we'll square the x minus 6 squared. Remember, squaring means to multiply by itself. So either use Euler distribution. Right? So here square and square root cancel. That would be x minus 4. Right? And so then we have x minus 6 times x minus 6. So we have x minus 4 equals, first term, x times x is x squared. Outer terms, negative 6 times x is a negative 6. Inner terms, negative 6 times x is a negative 6. And negative 6 times negative 6 is a positive 36. So we have, let's combine our like terms. We have x minus 4 equals x squared minus 12x plus 36. All right, now we got to move everything to one side, so we'll subtract x from both sides and add 4. Subtract x, add 4. So we have 0 equals x squared minus 13x plus 40. All right. Looks okay. All right, so we need two numbers that multiply to give us 40, but add to give us negative 13. All right, so, oops, I have them already over there. So negative 5 and negative 8, they multiply to give us negative 40. Negative 5 plus negative 8, they add to give us negative 13. So we have 0 equals x squared minus 13x. We're going to be, oh, excuse me, x squared minus 5x, right? So we're going to rewrite that negative 13x as negative 5x and negative 8x. So we have x squared minus 5x plus negative 8x plus 40. Factor out our greatest common factor. So from x squared and negative 5x, we can factor out an x. Divide both of those by x. We have x minus 5. Greatest common factor for negative 8x and 40 would be negative 8. Right? And so negative 8x divided by negative 8 is a positive x. And 40 divided by negative 8 is negative 5. So that repeating x minus 5 is one factor. And then what we factored out, x minus 8 is the other. And now we'll have to set our solutions equal to 0 and solve. All right, so I'm just going to, this the whole time should have said equals, oh wait, I have equals 0 over there, so that's right. All right, so now we're going to set it over here equal to 0. So we have x minus 5 equals 0. I'm starting to get a little bit tired. And then x minus 8 equals 0. All right, so that means x equals 5 and x equals 8 are our two solutions. We have to check and see if either of those work. 5 and 8, yeah, 5 and 8. All right, so we have x equals 5 and x equals 8. Make sure you check on the original solution. All right, always use the original solution because you may disguise a extraneous solution and make it seem like it is a real solution. So we have 5 minus 4 plus 6 equals 5. 5 minus 4 is 1. Square root of 1 is 1. And that's not a true statement. All right, so this one here, x equals 5, is an extraneous solution. All right, let's check the next one. All right, so we have square root of 8 minus 4 plus 6 equals 8. 8 minus 4 is 4. Square root of 4 is 2. And 2 plus 6 does equal 8. So that one checks. And this is a solution. And we'll give it the old happy face. And there we go. Another one is solved. Right? So we had one extraneous solution, one actual solution. Let's look at the next one. Right? So we have 2x plus x, the square root of x minus, let's read that again. 2x plus the square root of x plus 1 equals 8. We need to isolate our radical expression, so we're going to subtract 2x from both sides. All right, so we have the square root of x plus 1 equal negative 2x plus 8. We're going to square both sides. All right, square and square root cancel on the left-hand side, so we have x plus 1. On the right, we're going to multiply negative 2x plus 8 times negative 2x plus 8, so that will multiply. So we have x plus 1 equals negative 2x times negative 2x is a positive 4x squared. Right, then the outer terms, negative 2x times 8 is going to be a negative 16x. The inner terms, 8 times negative 2x is a negative 16x. And the last terms, 8 times 8 is 64. Let's combine our like terms by subtracting x and subtracting 1. Oh, I guess we should combine them and then we'll do that. So we have x plus 1 equals 4x squared minus 32x plus 64. All right, so now we're going to subtract everything. Minus x minus 1, so that gives us 0, equals 4x squared. Oh, and so here we're subtracting a negative x, or subtracting x and subtracting 1. So we have 4x squared minus 33x plus 63 equals 0. All right, so let's see if we can solve for x. Actually, I have it over on the side there. So 4 times 63 gave us 252. Two numbers that multiply to give us 252, but add to give us negative 33 or negative 21 and negative 12. I think I'll put the negative 12 by the 4x squared and the negative 21 x next to the 63. So we have 0 equals 4x squared and then minus 12x plus minus 21x plus 63. And then the first to our group, the second to our group, we'll plot our greatest common factor. So for 4x squared and negative 12x, that's going to be 4x, of course. If we divide them both by 4x, we've got x minus 3. Greatest common factor for negative 21x and 63 is going to be negative 21. Divide negative 21x by negative 21, you get a positive x. 63 divided by negative 21 is a negative 3. And then the repeating x minus 3 is one factor. What we factored out for x minus 21 is the other. Now let's solve. All right, let's solve over here. So if we have x minus 3 equals 0, x equals 3. And on the other one, it was 4x minus 21. So we have 4x minus 21 equals 0. We'll add 21 to both sides. 4x equals 21. and then divide by 4. So that doesn't reduce. X equals 21/4. All right, so let's check our two solutions there, 3 and 21/4. So x equals 3, x equals 21/4. All right, so we'll plug in the 3 first. All right, so we have 2 times 3 plus the square root of 3 plus 1 equals 8. 2 times 3 is 6, plus the square root of 4 equals 8. Square root of 4 is 2. And that one checks out. Let's check the other solution, the 21/4. So we have 2 times 21/4 plus square root of 21/4 plus. All right, so to multiply this, we're going to have to multiply one numerator and denominator by 4, so it would be 4 fours. Equals 8. All right, so this simplifies a little bit. This would be 21 halves plus. All right, so 21/4 plus 4 fourths is 25/4, which is a perfect square. All right, so you've got 21 halves plus 5 halves equals 8, and that would be 26 halves equals 8. Well, 13 doesn't equal 8. I don't think there's a mistake anywhere. Right? Let's go back here for a quick second, make sure I didn't write anything down wrong. So yeah, 21/4. And seems okay. So one solution. So this one's the extraneous. And this one's our solution. All right, on to the next page. This might be the last one. Nope. 2 more. Right, and then a little recap. All right, so we have 30 minus the square root of 30 minus 3x plus 4 equals x. All right, we got to isolate our radical, so we're going to subtract 4 from both sides. So that gives us the square root of 30 minus 3x equals x minus 4. Now we'll square both sides, so we have 30 minus 3x equals x minus 4 squared. Right, so square and to my equation there. Square and square root cancel, so we have 30 minus 3x, and then don't forget to expand. We have x minus 4 times x minus 4. That's going to be 30 minus 3x equals x times x is x squared. Outer terms, negative 4 times x is a negative 4x. Inner terms, negative 4 times x is a negative 4x. Last term, negative 4 times negative 4 is positive 16. So we have 30 minus 3x equals x squared minus 8x plus 16. Let's move everything to one side. So we're going to subtract 30 and add 3x. All right, so that gives us 0. Just checking everything out. I think it's okay. All right, so we have 0 equals x squared. That would be minus 5x and minus 14. All right, so I have it over there. All right, so what multiplies to give me negative 14 and adds to give me negative 5? That would be negative 7 and 2. All right, so we have 0 equals x squared minus 7x plus 2x minus 14. The first two are a group, the second two are a group. We'll plot our greatest common factor. So from the first pair, it's going to be an x. Divide x squared minus 7 by x, you get x minus 7. Divide 2x minus 14 by 2, and you get x minus 7. So the repeating factor is 1, and what we factored out, the leftovers, right, what we factored out is the other. And then we'll set, oops, we have too many zeros in there. We'll set our factors equal to 0 and solve. So we have x minus 7 equals 0, so x equals 7. And x plus 2 equals 0, so we'll subtract 2 from both sides. X equals negative 2. And now we'll check out our solution, 7 and negative 2. This is the longest video. 7 and negative 2. 7 and negative 2. All right, so 7 and negative 2. All right, so we have the square root of 30 minus 3 times 7 plus 4, and that's not under the radical, equals 7. So that would be 30 minus 21 plus 4 equals 7. That's the square root of 9 plus 4 equals 7, and the square root of 9 is 3. And that is a true statement. All right, so this one is a good solution. So we'll put solution and give them a happy face. Let's test the other one. So we have the square root of 30 minus 3 times, wait. Did I write the wrong thing from the last page? No, that was written correctly. X equals negative 2. Just want to double check. A lot can happen when I go from one page to the next. So that's going to be negative 2 plus 4 equals negative 2. So that is 30 plus 6 plus 4 equals negative 2. And that would be the square root of 36 plus 4 equals negative 2. Well, that's 6 plus 4 equals negative 2. And 10 does not equal negative 2. So here we have an extraneous solution. And because it's not a good solution, let's give him a sad face. And one more, and then a little recap. I think I might be able to keep this to 30 minutes. All right, so first step, isolate your radical expression. All right, so we're going to subtract 5 from both sides. So we have negative square root of x minus 3 equals x minus 5. Now normally we would try to isolate our radical completely, but it's just a coefficient in front. It's not going to really make much of a difference. And actually, I think I'd prefer keeping that x positive, that's the one we're going to be squaring. So don't worry, we'll just square the negative and it'll be fine. So we have negative square root of x minus 3 squared equals x minus 5 squared. See, I didn't really want a negative on the x there. All right, so if we square the negative, that becomes positive, right? So if we have a negative and we're squaring it, it becomes positive. So now we'll just have positive, we'll just have x minus 3, right? Because the negative will become positive when we square it, and the square and square root will cancel. So that's just an x minus 3. Equals, right? And so now we'll square, so that's going to be x minus 5 times x minus 5. Don't forget to expand that square, right? Expand to square the binomial, and then for use distribution. Right, maybe I'll use distribution on this one. So I have x minus 3 equals x times x minus 5, right? So I multiply the first term in the binomial by the second binomial, and then the second term in the binomial by the second binomial. So that's going to give us x minus 3 equals, so we'll distribute the x. X times x is x squared. X times negative 5 is negative 5x. Distribute the negative 5. Negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. Let's combine our like terms, and then we'll move everything to one side. So we have x minus 3 equals x squared minus 10x plus 25. And then we'll subtract x and add 3. Subtract x, add 3. So we have 0 equals x squared minus 11x plus 28. Right, so 1 times 28 is 28. It's also over here. Right, so multiplies to give us 28, adds to give us negative 11. It's going to be negative 7 and negative 4. Doesn't matter who's where. So we have 0 equals x squared minus 7x plus negative 4x plus 28. Oops. Well, that looks like 88. Right, and greatest common factor here is the x. If we divide both of those terms by x, we're going to have x minus 7. Greatest common factor for the negative 4x and the 28 is negative 4. If we divide both those by negative 4, we'll have x minus 7. Right, so what we factored out is 1, or excuse me, the repeating is 1, and then what we factored out is the other. So we have 0 equals x minus 7 times x minus 4, and if you set those both equal to 0, we have x equals 7, x equals 4. It's getting a little busy down there. All right, let's check our two solutions on the next page. And of course, if I'm going too fast for you to write down, which I might be, just make sure you pause the tape so you can take notes. All right, so let's check our solutions. And they were, if I change the page, 4 and 7. So we have x equals 4, x equals 7. All right, so we have negative square root of 4 minus 3 plus 5 equals 4. This would be negative 4 minus 3 is 1 plus 5 equals 4. Square root of 1 is 1, so we have negative 1 plus 5 equals 4, and that's a true statement. So x equals 4 is a good solution. Let's check out the 7. So we have negative square root of 7 minus 3 plus 5 equals 7. All right, so 7 minus 3 would be 4. All right, so the square root of 4 is 2, and negative 2 plus 5 equals 3, not 7. So x equals 7 is an extraneous solution. And now let's take a look at a little visual here to understand what's happening. Oh, and by the way, if I went too fast, just remember, just pause me, and then you can write that down. But let's go to our graph for right now. So solving radical equations and why there are some solutions that just don't work. So here we have the equation square root of x minus 1 equals x minus 7. And so here we're looking at solving it graphically. We have a graph. I'm not going to ask you to necessarily solve it graphically. But if I gave you a graph that you could understand that would be good. So here we have our two, and you're going to know how to graph, by the way, the radicals, square roots and cube roots in the next lesson. But there's the blue graph there is the graph of y equals the square root of x minus 1. And then the green graph is the graph of y equals x minus 7. That's just linear. So you can see there should be a solution at or about x equals 10. That's where those two intersect. And if they have one point of intersection, that means they have one solution. To solve this algebraically, I need to square each side. Right? So we'd have square root of x minus 1 squared. That's going to give us x minus 1. X minus 7 squared. I just kind of skipped a couple steps there. It would be x squared minus 14x plus 49. And then this continues on the next page. All right, so here we have x on the right-hand side. I'm talking right here. All right, so we have x minus 1 equals x squared minus 14x plus 49. Right, we'll subtract x, add 1, we get x squared minus 15x plus 50. Multiplies to give us 50, adds to give us negative 15, would be negative 5 and negative 10. Right, so we rewrite the negative 15x as a negative 10x and a negative 5x. And the first two are our group, second two are our group. All right, so now we have x times, we got to factor out the x, right? So I'm right here now. Right, so greatest common factor for x squared and negative 10x would be x. If we divide both of those by x, we have x minus 10. Greatest common factor for negative 5x and 50 would be negative 5. Right, and so we have x minus 10. All right, so the repeating x minus 10 is 1, and the leftovers, what we pulled out, is the other factor, x minus 5. All right, so we have two solutions now, x equals 5 and x equals 10. Now, if you look at our graph here, so here we have graphed our two sides now. All right, so what did we have after we squared? All right? We had, so here we have, let me write it in, so I'd be right over here. Right, so this is the blue graph there, x minus, oops, I grabbed a green pen, x minus 1 there. So right here we have y equals x minus 1. And then this would be the green graph, y equals x squared minus 14x plus 49. And when we squared, now we got an extra solution. Right? Now the line intersects twice. And when we check out x equals 5, that does not work because 2 does not equal negative 2. So that's not a solution. That's an extraneous solution, right? Extraneous solution. So sometimes when we square, because we change the equation to give it an equation that has 2 solutions, we sometimes get an extra solution that's just not a solution because it's extraneous. Right? And so here's just a little visual example of a visual graph. I'll look at a visual graph so that you can see why we sometimes get extraneous solutions. And that's the end of this podcast. And these 5 here are the whiteboard practice. Right? And don't forget to check your solution. And don't forget you'll have to factor in all of these. All right, so bye for now.